to the cloud. And we're doing that. Okay, so this New York AE chapter on UV in the COVID era. And just quickly, I wanted to share with everybody that AE West is coming up. That's the regional conference out on the West Coast, similar to AE East or GlobalCon that we've often had here on the East Coast. Though this year, everybody gets to go to that without having to get on a plane, which I guess is not necessarily a good thing for the reasons we're doing it. It's only $49 for members, and I'm going to shoot out that link to everybody. And there are quite a number of both keynote and technical sessions and panel discussions, as well as opportunities to interact with exhibitors, as well as other networking. I really highly suggest folks to take a look at that. I know I'm going to be participating. I also wanted to point out the New York chapter. In about a month, the board is going to be getting together to plan next fall through spring's meetings. If there are any topics or speakers that you're interested in hearing about or hearing from, please let myself or any of the other board members, NYAE board members, know about that. We want to present that stuff that's of greatest interest to our members, to you guys here. Also, chapter awards, we'll usually do that this month at our awards gala. Because we weren't able to have the gala in person, we're a little bit delayed on going through that process. So if you know any individuals, projects, organizations that have done or are doing good work, please let myself or one of the other board members know about that, because we will be hitting that as well, doing that as well. At this point, let me quickly introduce our three speakers for today. Dan Zagata is based out of New York City here. He has a background that includes more than 15 years experience, the past 3 years as Director of Business Development for Sterile Air. Sterile Air is a US manufacturer and global provider of high-powered UVC emitters used to enhance indoor air quality, microorganism and control inactivation, green building, and well credits, as well as energy savings. His prior experience includes 12 years as a sales engineer for industry-leading manufacturers, rep organizations. He has a background in mechanical engineering and consulting engineering, mechanical contracting, and consulting engineering community, specializing in HVAC construction. He has a BS in mechanical engineering from UMass up at Amherst. Ray Crespo is the co-founder of ECS and has more than 25 years experience in the field. And Ricky Dweck is the Executive Vice President at Energy Conservation Supply based here in Brooklyn, New York. Ricky has been with ECS since 2009 and has designed, installed, managed several million square feet of energy efficient lighting and controls upgrades across the United States. Since the pandemic, Ricky has become the in-house guru on UV lighting technologies and applications in commercial and industrial applications. With that, I want to turn this over to Dan to start us off.
Okay, thank you, Fred. I'm going to kind of breeze through this really quick. This is a PDH presentation that I do for consulting MEP firms. We don't have a lot of time, so I'm going to speak fast and kind of breeze through the slides. So just want to say that if anybody has any questions or would like to reach out to me personally, I'm more than happy to answer you offline on an individual level.
Oh, actually, Dan, just one quick thing to everybody. Uh, If you have questions as we go along, we ask that because we're such a large group here, you just use the chat function to chat your questions to the host. One of our board members, Tim Lynch, is getting that and is going to compile those for all the speakers when both of them are done, both sets are done. Go ahead, Dan, sorry.
Thank you, Fred. So like Fred said, I'm Director of Business Development for the last 3 years for Sterile Air. Sterile Air as a company since 1995 had introduced using UVC in the HVAC systems of a building. So we basically, as a company, created a patent, an applications patent to address the cooling coil and the drain pin on an HVAC system as the single largest reservoir and amplification device of microorganisms and pathogens in the entire HVAC system. So the benefits of using UV for germicidal or radiation and bacteria, virus, and fungal control goes back to the early 20th century. However, what Sterile Air did was we took it into actual field conditions. With the advent of central air in the 70s, we basically turned our buildings into giant incubators, recirculating sometimes dirty air. So we need to account for what those conditions are: the lower temperatures, the dark corners, the condensate that's being produced by the air handler itself. All these are ripe conditions for biological growth. So Sterile Air's approach is to install a bank of UV downstream of the cooling coil to eliminate biofilm from the face of that coil as well as from the drain pan. And when we're dosing in such high intensities, and I'll explain that in a second, when we're dosing in such high intensities, we're also getting what we call flyby production. So once that coil has been cleaned of the biofilm, which is also for the purposes of energy savings, is creating a large fouling factor and making that equipment operate very inefficient compared to what its design point should be. We're eliminating biofilm, which acts as a food source for other organisms, other microorganisms that are coming back into the system by the occupants in the building every single day. What we are, we're an energy-based design. Scientific analysis, what Dr. Ulrich is saying, we want to know what these organisms, what the properties of the organisms that we are addressing are. So Sterile Air was founded by Dr. Robert Shire. Dr. Shire is a doctorate of microbiology, and he understands that each one of these unique organisms has a different energy base, which is needed to inactivate in different percentages. So we have, when you're dealing with the efficacy of UV, there are 3 variables you need to consider. You have dosage, which is ultimately the amount of energy that's needed to inactivate a given organism at specific percentages. You have intensity, which is the amount of energy that the UV itself is creating, and you have time. Time is very specific. When you're dealing with static coil cleaning, time is how long does it take us with a specific intensity of the UV energy bank to meet the dosage needed to inactivate this organism at this percent. When you're talking about non-static air disinfection, time is how much exposure time do we have of air to the actual bank of UV. So those are the 3 variables that are going to determine how effective your UVC system is in organism control and virility and in population and colony forming units. Dosage, intensity, and time. Dosage equals intensity by time, multiplied by time. Water and air quality. We're very conscious of the quality of our water, and we're only drinking 2 quarts of it a day. What about our air quality? Are we nearly as conscious? Up until the COVID hit these shores, air quality was kind of on the back burner. Was it treated? Were people even aware of how poor the quality of the air they were breathing was? You know, you wouldn't make a sandwich with moldy bread if you saw it. And just because you're not seeing it doesn't mean these organisms don't exist. And they don't exist in your airstream. We have cultured any number of different coils over any number of different industries. And I can tell you that there are common organisms that exist on every single one of them. ASHRAE, they recognize that these organisms are actually airborne. If you look at the last bullet point here on this slide, what you're finding is, yes, these organisms exist and they're transmitted throughout the airstream. How is this occurring? How does biofilm occur? You have your condensate on the coil, so you have moisture from the condensate, along with dirt, skin flakes, defecants that are passing through your filter banks, bypassing them all together, along with different organisms like viruses and bacteria and mold spores that are also passing through your filter bank or bypassing it altogether. They all adhere together to create biofilm. Now, biofilm is actually a living matrix of any different number of organisms. Any organism that's introduced into the space and sucked up into the return of the air handler on an untreated coil, it will attach to the biofilm and it will continue to grow. And bacteria and viruses, when they have conditions like such that exist in a cooling coil cabinet, those cold temperature, good humidity levels, darkness, they will double themselves at a rate of every 20 minutes. So untreated coils you can have a single organism break out into trillions of organisms quite quickly if you have an untreated coil. What else does biofilm do? Huge energy losses on your coil. What are we basically doing? We have very expensive equipment and we're using a whole lot of energy to try and transfer temperature. When you have less efficiency, when you're less efficient and able to transfer to that temperature, you're losing a whole lot of efficiency, and that's costing a whole lot of real dollars in trying to get thermal comfort. Actual before and after pictures. On the left, that is biofilm. On the right, post UV-GI treatment, no more biofilm. And a definition of biofilm. Okay? It is a living organism. Well, it's a matrix of living organisms. We talked about how it attaches, it grows, and detaches. When you have biofilm on the coil or in the drain pan, when the air system kicks on, it's detaching those organisms that comprise that biofilm and it's sending it off into an occupied space untreated. So now the occupants of that building or the space in which that air handler is feeding are now susceptible to breathing in these organisms and taking them into themselves. What else it does in restricting our airflow, lowering our CFM. We talked about how it becomes the largest reservoir of microorganisms and a large amplification device. In other words, as an aerosol generator, you're basically, your airstream, your HVAC system is sneezing into the building. It's sneezing all these organisms that had made up this biofilm and are continuing to grow on untreated coils. Reducing HVAC efficiency. These are bullet points. One of the things that I would also point out or ask you to focus on here is lowering maintenance. Once you treat the coil and you remove the biofilm, you have a self-cleaning coil. So once those organisms the last of the organisms, living organisms, which are going to be mold spores, that remain on that biofilm, condensate is going to run that biofilm down the drain, and now you have a self-cleaning coil. You no longer need to additionally clean that coil whatsoever. Associated labor costs, those are all gone away. And another thing that you can now do is, because you have clean water condensate, you can actually repurpose that condensate. We have white papers, and at the end of my time, I'm going to kind of point out these different white papers that we have discussing the efficacy of UV when it's used properly, energy savings, and condensate recovery use. So the more fouled up a coil is, the less efficient it's operating. We have seen with different fouling levels, now we're increasing we're losing up to 33, 35% efficiency in our coil. That's significant energy. The HVAC system of a building on average is using anywhere between 40 and 60% of a building's entire energy expenditure. So when we're talking about real dollars, a 33% less efficient coil is just wasted dollars for that building in energy costs. It's just going out the window. That culture right there is a very common sight we see on pretty much every coil or supply and return air diffuser that we test for. You can see what is happening when you sample it and you seal it and you just let it grow. It'll start to flower within days. What you're looking at here is a mixture of bacteria and fungal spores. What do we find on pretty much everything we culture? Aspergillus niger. Going back to the design point, Aspergillus niger is going to be the hardest substance in order to inactivate. It's basically just regular black mold, okay? Our sterile air's design point is to ensure we have a minimum of 1,225 microwatts per centimeter squared across that entire coil. Okay, that's going to inactivate at the end of the useful half-life of that emitters, which is 9,000 hours. We still have enough energy to inactivate all Aspergillus niger in roughly about 9 minutes. But because we're designing at that initial intensity across the entire coil, our flyby production, so our air disinfection for bacteria and viruses, is spot on. We can run those calculations with specific variables. We just need to know what the air velocity is and what the area and the area of air suspension that exists in that cabinet. And once we determine the exposure rate, we know fixed dosage variables, because every single one of these organisms you see, and all bacteria and viruses, they all have fixed dosages needed to inactivate them at different percentages. COVID, for example, well, it's surrogate, which is SARS-CoV-1. There currently are no exact tests for SARS-CoV-2. And Dr. Kowalski, he kind of has stated that they're unnecessary and they're also dangerous, which is why tests have not been done to date. But it's surrogate. We know that you need 6,372 microjoules of energy in order to inactivate 99.99999% of this particular organism. So that's what we can size for. So again, sterile air system, we're treating the coil, removing biofilm and all the inefficiencies with the coil it creates, as well as removing the food source for everything that exists downstream of that coil. And we're also getting flyby productivity for every new pass when new organisms are introduced to the building by the people who occupy it, and it gets sucked up into the return air, passes by the UV bank, and it gets treated again before it gets sent back out to occupied spaces. Different bacteria that we're finding on pretty much every coil we culture. Pseudomonas aeruginosa, that is a bacteria that causes pneumonia. Okay, that also in hospital situations, that little bug right there is responsible for, I don't know how many deaths per year, but it's quite a lot. It's also responsible for roughly $60,000 per hospital acquired infection. And there are 99,000 of those a year. So we're talking about billions of dollars when that little guy gets stuck in a hospital environment. And again, they're in the airstream and they're on the coils themselves. Staph, another one, strep. These are all organisms that everyone's familiar with. Now, how is COVID and really any organism being transferred? It's being transmitted through bioaerosols. So you have larger droplet nuclei. They typically fall to the floor. They have very short half-life. We're not too worried about their transmittability. What we are worried about is in really small droplet nuclei that exist through even normal conversation, okay? But even more so when you're talking about a cough or a sneeze, okay? These small droplet nuclei that occur during coughing, sneezing, singing, normal conversation, they can remain suspended in the breathing zone of a building for hours or even days, and they'll spread great distances, and that's before they get sucked up into the return air. Now, once it gets, let's say somebody COVID positive, sneezes into a building, okay, those droplet nuclei turns into a bioaerosol, and the people who are in that building are susceptible to breathing it in, but ultimately that organism is going to get sucked up into the return side. And if your coil is not treated or your air isn't treated in a high enough dose to inactivate that organism, which again we know is 6,372 microjoules per centimeter squared, that is going to attach to the biofilm that exists, and it's going to start growing. And now every time the air kicks on, it's going to sneeze out COVID-19 into the building. Everybody who enters that building is now at risk of catching not only that organism, but the other organisms that comprise the biofilm. This is just how fast, the sneezing generates more biofilm. What's being said, this is industrial hygiene chart. It's kind of hard to see, but bacteria and viruses make up a great percentage, over 96.2% of indoor air pollutants. And 98% of these that are germ causing, okay, infectious disease causing, remain permanently suspended into your breathing zone. So we're talking about really small micron organisms, strains of organisms that are so small, even the best filters can't really trap them. What does ASHRAE say to do about your air quality? It's very simple. There are 3 safeties that they put in place. It's the only safeties that are recognized by ASHRAE. They are ventilation, dilute the air, more free air. They are filtration, better filters, catch more filters, change your filters more, electrostatic filters. These are great new advancements in filtration. And then, of course, organism viability by ultraviolet treatment. That's it. ASHRAE just actually re-released their position on airborne infectious disease control on April 13th this year, valid through 2023. And it says the same thing. These are the only safeties that are recognized by ASHRAE as being effective. Best filters, this is a typical system, 800 CFM, 80 million particles are gonna approach that filter every single minute. Even if you have a 99.99% efficiency, that still means 8,000 particles are passing through the filters. 24 hours, it's almost 12 million. We talked about how mold and viruses double in optimum conditions, such that exist in a cooling coil cabinet with the moisture, the humidity, the condensate, the moisture, and the dark, cool temperatures. They're prime breeding grounds. They will turn into 24 hours up to 70 trillion organisms. So we're talking about really, really high concentrations of different organisms that can happen very quickly in untreated systems.
Wow.
I'm sorry, was there a question? Okay, mold is a little slow. We have a lot of tertiary studies which you may find interesting. My favorite is Buffalo Women's and Children's Hospital. It was over 2.5 years. And what was happening was infants were being born and they were dying in the NICU. They traced it back to the NICU environment. And we did this in conjunction with 4 other organizations. And throughout that entire NICU environment, you can see what are the organisms we found. We found them everywhere. We found them in the air diffusers. We found them on the coil. We found them in diaper weigh stations. We even found them in infant trachs. So this was resulting in loss of infant life. And over that 2.5 year span, what did we do? Pre-UVGI, we found 1.25 million colony forming units of bacteria that exist on the coil and the drain pan. Post-UVGI, 90 days, okay, that colony forming unit went down to 125 colony forming units per square inches. For fungal organisms, 86,000 down to 2,000. I mean, that's significant. And going back to what I said, with Sterile Air's high output emitters and designing our cooling coil dosage to be at a minimum of 1225 microwatts per centimeter squared across that entire coil, we are able to be highly successful in air control, air disinfection flyby. So if you look at the supply and return air diffusers before the UVGI, 815,000 colony forming units per square inch of bacteria. After post-UVGI installation, down to 1,400. I mean, these are significant results. UVGI, when it's sized properly, is extremely effective in organism viability. There is no need to reinvent the wheel, folks. This is your best practice. You want to use UVGI in conjunction with good filtration and good ventilation. More numbers, 1.8 million pre-colony forming units per square inch down to 33. I mean, these numbers they speak for themselves. And this study was actually published in the Journal of Perinatology. It was published in a completely third party, nothing to do with sterile air, just detailing the results of that particular installation. Talked a little bit about ventilator-associated pneumonia. I'm not going to talk too much about it, except for the fact there are 99,000 plus cases of hospital-acquired infections a year, and the average cost in them is about $57,000. So if you multiply that over 99,000, we're talking about loss of revenue in the billions. Big money. Final results of Women and Children's Hospital of Buffalo. $800,000 a year in reduction in direct costs through reduced ventilator-associated pneumonia, antimicrobial use and resistance, as well as energy savings by having cleaner coils running more efficient. The initial investment was only $25,000. More ASHRAE. I'm not going to go too much about the UV light spectrum, but there are different wavelengths of UV light. We're operating in the 254 nanometer wavelength, which is giving you your best germicidal irradiation. There is this particular wavelength of UV does not penetrate glass or most plastics, so you do not need to have to worry about adding a tint or a special glass on any of your air handlers, sight glasses. This is something that I do want to point out, and this is about as salesman-y as I'm going to get with you guys. But back when anthrax was a major concern, the U.S. Department of Homeland Security, in conjunction with the EPA, they were trying to figure out different ways to combat this. So what they did was they took 10 of the leading UVC suppliers and they tested for the efficacy of them. And here's what they found out. On a watt-to-watt basis, so with the exact same power available, and a pure apples-to-apples comparison, on average, sterile air emitters were 6 times greater than that of the other UVC suppliers. What does this mean? Go back to how is UV efficient? How is UV effective? It's dosage, intensity, and time. So if we have a higher intensity, we're able to lower our time requirements to meet specific dosages. But if you do want your UV to be effective, you absolutely, against different organisms, you absolutely 100% need to hit different dosages. And whether you do that by prolonging your time or adding intensity to your UV, that's the only way that you can get more effective. So by having on a power-to-power, watt-to-watt basis, apples to apples, same length, having an emitter that is on average 6 times greater the intensity is a huge bonus, and allowing us to be effective on flyby and air disinfection while we're treating the coil. We don't need
Dan,
yeah.
Dan, I see we're kind of just a couple moments over time. We have a load of questions, but I want Ray and Ricky to have a chance to do their presentation, and then Tim's going to share those questions. Okay?
Sure, not a problem. Can you give me 2 minutes? Can
we keep it to 1 minute and go for it? Okay.
So this is an actual study that was done on a CWC coil. Pressure, and this goes to the energy side. Pressure drop went down. There's a 1 month period. Pressure drop was able to drop by 28% across the coil. CFM went from about 16,000 to 17,000. So an 8.6% increase in CFM. And 3 and 4 degree greater temperature differential across your wet and dry bulk temperatures. So these are all ways in which we're able to increase the efficiency of a properly designed UVGI system. We can talk more in the Q&A section, and I have some documents that I would like to share with everybody on this call. And I think that was less than a minute, Fred, so I'm good to go.
That's great. Thank you. Ray, do you want to jump on in there?
All right. Thank you, Dan, for all that great information. Really appreciate it. I just want to thank AEE and the members and everyone for dropping in on this webinar. very difficult time for everyone. Thank you very much as we start to reopen. We believe UV is going to be an important part of the process of reimagining and reinventing our workspaces and our live spaces. So just in case you don't know, ECS is an energy conservation company. Energy Conservation and Supply is the name. And we were founded in 1995 by my father, Bob Crespo, and myself. We are distributors who design, build lighting and lighting control upgrades across a multitude of business sectors. If there is a business sector, we have touched it, whether it be a retail or hospital, industrial space, commercial space. So when SARS-2 and COVID-19 appeared on the scene, Ricky Dweck jumped into action to determine how ECS could best serve our business community, our friends, and the people of our neighborhood. And as subject matter experts on lighting, we have been at the vanguard of energy efficiency and lighting uses since 1995, whether it be from T8 lamps, compact fluorescents, HID, and LED. We have been there through this entire process the last 25 years. And based on exhaustive research by Ricky and his team, as well as feedback from our clientele, the guidance from the CDC, and all the various experts that are out there, we have found that in terms of commercialization in lighting, the Puro UVC light is the most efficient way to provide a localized environmental response that is proven to be effective against the coronavirus that causes COVID-19. So without much further ado, I'd like to pass it on to Ricky Dweck, who, as Fred mentioned, is our guru relative to UVC and everything that relates to surfaces and transmission. And moving forward, thank you very much. And off you go, Ricky.
All righty. You can see the screen okay?
Yes.
Perfect. Okay. So thank you, everybody. Thank you, Ray, for the introduction. Thank you, Fred. Thank you, AEE. Thank you, Dan, for that amazing biology lesson, which makes this a lot easier to jump through sort of the product highlights and a little bit about what we present. So you said we're representing Puro from the manufacturer standpoint. To jump on to what sort of Dan a little bit ended up off on some of those slides is that this specific product was designed for the healthcare community to help prevent and fight healthcare acquired infections, which is basically about a $35 to $45 billion a year cost to health insurance companies and hospitals when people get those infections. So assuming or making the assumption that the hospital is not going through some HVAC disinfection, Puro's sort of space is on surfaces and in rooms and how to quickly and efficiently disinfect those areas to prevent HAIs. This technology has existed, or the known properties have existed of UV, as you mentioned, for 100 years. It's been used in health and hospitals for about 20 years, primarily through the use of these push carts and these large, expensive robots that are wheeled into these rooms to disinfect. Very expensive. And Puros came to market and said, how do we miniaturize this? How do we make this portable? How do we install this similar to a light fixture? So a lot of the guys behind this product came from the lighting community and said, hey, we need to install this in a ceiling, on a wall. We need to have connectivity. We need to do this on demand. How do we create a product that solves all of these problems? In addition to that, knowing that this is a healthcare product, it was very important to have independent clinical lab validations and support. So back in 2017, when they first launched this product, they have all of the clinical data to support all of the claims about what the product can and can't do. The most exciting thing that's really happened in the last 3 weeks is New York City publicly announced the use of this device to disinfect subway cars and buses. And what was really exciting was Columbia University is working with the MTA to validate the efficacy of the product. And if you go on to Google, YouTube, you can look up this gentleman named Dr. Brenner, who's one of the leading people in research on UV devices and their efficacy against killing viruses and other pathogens. So Columbia University is in the process. They have not actually published the report yet, along with the MTA, on its effectiveness of killing COVID-2, specifically with this device. So we're excited or hoping that that comes out in the next 4 to 6 weeks. We also, much to what Dan said, is this device specifically has not been tested on COVID-2. We are in the process of testing the surrogate, and we're hoping to publish that data as well. And then there is some other data out in the, or other studies that have been published in the field or by other companies using similar technologies that say that they can kill it in 2 minutes, a few seconds. I think I just saw Signify announce today that they can kill COVID with UV. So it's sort of this global acceptance that UVC is effective in killing COVID. Now it's just a matter of having the clinical data to back it up. So as mentioned, the product specifically, it can either be portable. It has a universal VESA mount pattern bracket on the back. So these examples of whether it's on wheels or on a tripod can be moved into a space. And as little as 15 minutes, you can disinfect the space. One of the technological aspects that's different than most UV devices is that we use a pulsed xenon lamp. So very different than some of the quartz or mercury or the fluorescent style lamps that you see. And one of the advantages of the pulse xenon lamp, and again, I'm going to continue to reference back to Dan, is that dosage intensity and time plays the same factor. And with a pulse xenon lamp source, we are able to increase that intensity using a very high intensity light, using a broad spectrum of UV. So this device uses UVA, UVB, and UVC. It pulses it every 6 seconds. So you're getting a very high intensity, high dosage burst of light every 6 seconds through that cycle, which is then shocking, killing the DNA, RNA structures of those viruses and bacteria in the space. The unit also has 2 fans, which help keep the heat down. And one of the other aspects of the unit in which you use these microbursts of energy is that it also is less degrading to plastics, rubbers, fabrics that are subject to some fading when they have exposure to UV. So that's some of the reasons why this is really a great application for use in certain spaces that won't affect it. Very exciting from the energy standpoint, as well as connectivity. For anybody that works in the mechanical space, is that this is a BACnet compatible device. So if you were to install it in a ceiling or on a wall, you can you can integrate it into your BMS and have full control. So when we start talking about automation and all the things that you can do in buildings, very unique in that, how are you right now confirming that you're cleaning and that your disinfecting is actually happening? How do you audit that? How are people, because traditionally disinfecting is done by people going in with a rag and a bottle of bleach. How do you confirm disinfecting is actually happening in spaces? How do you confirm that the dirty mop bucket water is working? How do you confirm that people are actually following the CDC guidelines of cleaning and disinfecting, which are 2-step processes? So it's very, very hard to audit. And in all the conversations that I've had over the last few months, I think I've only found 1 or maybe 2 people that have hired a third-party lab to come in and do swabs of surfaces to confirm the effectiveness of their traditional cleaning. So what's really unique about the product and the feature here is that you can confirm the disinfection cycle, and you can automate the disinfection cycle, and you don't have to replace it with your standard janitorial, but this can go as a secondary level to confirm that disinfection is actually happening. As far as safety is concerned, right, UVC is not for humans. Humans should not be exposed to UVC. It's harmful to skin, eye irritation, can cause damage to cells, and so on. This device has a built-in aux sensor. It will not turn the unit on if motion is detected, and it will shut the unit off if motion is detected. So when we talk about use and applications of use, one sort of idea is in a restroom, right? You can disinfect that restroom on demand or automatically. when nobody is in that restroom. So you could actually have constant disinfection going on all day long, or you can put that on a schedule using the BACnet and BMS integration. It's also really interesting. You have chemical-free disinfection. So everybody is using chemicals right now to disinfect. This is an alternative. Some places like that, some places don't. But I think chemical-free disinfection for one of your strategies is great. As far as energy consumption, I think this is one of the lowest energy UV devices out there in the market that is also effective in killing viruses and pathogens, because like you said, you go through dosage, intensity, and time. With basically a 30-minute cycle on the smaller unit, you're using only 40 watts of energy to kill viruses and pathogens, where some of the other units, each lamp is 40 watts, and you have to run those continuously through a period of time. Product is made down in Florida, foreign and domestic components, but locally manufactured. Just some ideas of where this is being used today. Hotel rooms are adopting this as a secondary disinfection to after the cleaning staff comes in. Again, it comes from the healthcare market. So you see, go back. It's being installed on walls to disinfect ORs. A lot of outpatient surgical centers are using this right now. We're seeing, and because again, this comes from the lighting space, it lays across a 2x4 T-grid ceiling on the larger unit. We're not seeing a whole lot of adoption right now in the commercial open office environment, just because it is expensive to start putting these every 10 to 15 feet. Where we are seeing it is in those high touch, high trafficked areas, cafeterias, schools, mail rooms, lobbies, elevators, fitness centers. Don't have to go again into the UV spectrum, but what mentioned is the UVC is what effectively kills viruses. This it falls in the lighting community, but it actually is more of a consumer electronics device or a medical device. So all of the certifications that we were able to obtain for the device between UL listing, the EPA registered facility, it's FDA cleared for food and medical areas, FCC tested, etc. One point I like to just make is, again, because it's been on the market since 2017, very simple. Viruses are classified into 3 categories, 1, 2, and 3. Class 1 viruses are the hardest to kill. Class 3 are the easiest to kill. The EPA has an emerging pathogen guideline that says as long as you can kill above what you're claiming, you're legally allowed to make that claim. So even before MTA tested it with Columbia and some of the other studies came out, this was tested on norovirus, which is a class 1 virus. And we confirmed the efficacy and ability to kill norovirus in a, I believe, 36-minute cycle of running the unit. Coronaviruses are in class 3 viruses. Those are the easiest to kill. And again, some of the studies and what we're finding is that we're probably going to be able to confirm, once it is confirmed, in just a few minutes, being able to kill coronavirus. I didn't bring all of the clinical validation. We have the detailed list of everything that was tested and the distance it was tested and the time it was tested and what you're able to kill. Some other ideas that just sort of been going on just in general about what you can disinfect with an on-demand or sort of a UV light. You can disinfect anything from tools, whether it's contractors coming into buildings and wanting to have it that way, whether it's mailrooms and packages or it's daycare centers and things like that. You can basically disinfect anything. We have it with a UV reflective tent, which can basically reduce the kill times to 5, 10, 15 minutes, depending on the size of the area, using highly reflective tents. I'm not going to get too much into HVAC because I'm not an HVAC guy, but I will just show, and just Dan, and maybe after we can talk about this, is that this is a strategy, right? So there's not a one-size-fits-all strategy as it relates to disinfection, but Similar with the coils, is this device can be used as a coil disinfecting strategy. But based upon what that unit looks like and what's in the space. There's some images of elevators and restrooms and fitness centers, and that's pretty much the product.
Great. So are you to the end of your slides, Ricky?
Yeah, that's the end.
Okay, great. Well, I want to thank all three of our speakers. At this point, I'm going to turn it over to Tim Lynch, one of our longtime board members who has been watching everybody's questions. I hear we have quite a number of them. Tim, if you want to go ahead and ask those to our speakers. You got to take yourself off mute.
There we go. Okay. Yes, questions have been coming in fast and furious. And they are going to present them in the order in which they were received. Any research, and this is for Dan. Is there any research done? Actually, Dan, let me go through your questions, and then, because there may be some commonality to them. Okay. Is there some questions for Dan? Is there any research done on 405 nanometer light spectrum for germicidal effects? Can this eliminate bad effects of UV? There was another one from W. Pockles that says, not important, but an earlier slide referred to American Society of Industrial Hygiene. I believe that he meant American Industrial Hygiene Association. Yeah. And then he also asked, or Statler asked, I am curious how long organisms can travel through a ductwork and fans, coils. So you said someone entering a building can transmit organisms in the building space and then go to the return system and then back to the delivery system. They must be very resilient. Please comment. I understand there is moisture in dark spots that can breed. Mike Bobker, another board member, asks about, is it significant?
Tim, why don't you let him answer the first few questions, and then we can go on to the next, I guess.
Okay.
Yeah, so I mean, the organisms, I'm going to start with the resiliency of the organisms. If an organism is not clinging to a surface, it is going to remain suspended in the breathing zone. And ultimately, that is going to create air passes that cycle through your HVAC system. So if you don't have any treatment whatsoever, particularly on your, let's just keep it to the coil. If the coil's not treated, there is biofilm that exists on that. And let's say you did have a bank of UV energy on the return air side. So there was UV treatment on the return duct, which has a certain intensity that it's able to create. That intensity, depending on how fast the airstream is, because the air velocity in the return air is going to be a whole heck of a lot faster than it is in your coil cabinet. Depending on how fast that is and how much intensity you're creating is going to determine what organisms and what percentages can actually get by that UV treatment and add themselves or adhere themselves to the biofilm that's existing on an untreated coil. So yes, that absolutely happens with bacterias and viruses alike. Okay, viruses are not living organisms. Viruses are strictly a protein coat that houses RNA, DNA, and nucleic acid. They need a host on which to travel with. That host can be bacteria, that host can be fungal, and yes, they will absolutely be sucked up into the return air. What was the other question? I'm sorry, Tim. Well,
how long can, yeah, I think there are some additional questions there. It's from Mike Bobker. It's significant to recognize that virus does not replicate outside a living host, so will not increase in concentration within a coil the way a bacteria or fungus will. Evidence is shown about bacteria. What is demonstrated regarding virus destruction and UV, I've heard the UV intensity necessary to destroy virus in airstream is much higher than what is typically designed for intensity applied to keeping coils clean by controlling the development of biofilm.
Significantly, because you're talking about non-static air disinfection versus static coil cleaning. Static coil, I mean, you just have UV that's being dosing a coil. All it needs is time to create that dose. So time could be 9 minutes, that time could be 90 minutes. You know, it's not going to be nearly as important as when you have air that's flying by that needs to be taken care of in one single pass. You cannot size air disinfection system to be effective and say, oh, I need 3 or 4 passes to be effective, because at that point you have a fluid environment. You're having organisms that are constantly coming in by the population of that building. So yes, if you want to size your air disinfection appropriately, you need to factor in the air velocity, and you need to factor in the area and the straight line length of duct run. Or in our case, what I'm talking about is how deep is the cabinet, what the area of the cabinet is that air is going to be suspended, and for how long, so it can be dosed with the UV bank, with whatever intensity the UV bank is creating. So yes, Mike is absolutely right. These are all variables that need to be taken into account when you're sizing these systems appropriately.
Okay, another question from David Fair.
Yeah, there's no one stop, one drop-in solution. You know, every single application stands on its own merits.
Thank you. That's exactly the clarification I was looking for.
Okay, that's a good question, Michael.
Another question from David Ferris. Is there a UV light application shining on an energy wheel to counteract leakage from return to supply? Is there a comment on degrading organic material in filters and maybe on the energy wheel itself?
Repeat the last part of that question.
Basically, is there any UV light application that shines on an energy wheel and to counter leakage from return to supply, and also please comment on the degrading of organic material in filters and maybe on the energy wheel itself?
So there is always a concern. I'll start with the latter part of that question. There is always a concern with having a constant dosage of UV and how it's going to hold up. Most specifically, is it going to compromise the integrity of that material, or is it just going to create some slight discolorations but will have no effect on the performance? What we have found is older units, that was more of an issue. Nowadays, plastics and rubbers and other materials are so highly fibrous that they can hold up to a constant and a high intensity dose of UV fairly well. That being said, we have a list of materials that we have tested for in the past, and we have them classified as to how well they hold up into two sterile airs UV. I want to clarify that as well, because we're talking about high output UV. Classify very good, good, fair, moderate, poor. And those are based on time exposures to that material. You know, like, are we talking about how will a material hold up in 5 years versus how it will hold up in 10 years? And that's gonna put it into a classification. Any new wiring that is UL listed is perfectly fine. It will hold up well to constant UV. The thing that I would suggest is when you're talking about older units and retrofits, if there's a concern whatsoever about any of the material, wrap it in aluminum tape. Cover any gaskets or any wiring in aluminum tape. Aluminum is very reflective of UV. which is also one of the reasons why we're able to be so effective when it comes to coil disinfection, because most coils are aluminum themselves. So even on the 12, 14, 16 roll coil that's extremely thick, we're able to penetrate through the entire coil to make sure that we are eliminating all the biofilm that can exist because of the condensate and the moisture that's produced by the condensing coil itself. First part of that question again?
No, I think you've answered that. It was mostly pertaining to UV light application shining on energy wheels and how it affects materials.
So yeah, so the ERVs are typically like they're typically downstream of a coil, which means that they are getting treated in any moisture that may exist. Moisture is the key element when it comes to, okay, will this component possibly have biofilm or not? It needs to have moisture, which is why we will not treat a heating coil. There's no need to treat a heating coil because there's no growth that's even possible. So the UV, and in the cabinets that I've seen, there can certainly be manufacturers out there that have different designs, but the UV will typically hit that ERV well enough to eliminate the possibility of biofilm being produced by any sort of moisture that is coming off the energy recovery wheel.
One more question to you, right, Dan, is from Lou Rugolo. Can you talk about commissioning process for UVC installations, measurements across upstream, downstream face coils, instruments, any certification required?
Any certification required as to who can perform the testing?
Commissioning process for UVC installations.
We have a detailed procedural list on how to go about doing that. One thing I would like to point out that I'm glad this question was asked, we're currently in conversations with Con Edison right now about getting a rebate for installing UVC in the HVAC system. This would be done through their new technologies group. I don't want to speak too far out of school, except to tell you that we've identified 2 pilot systems. One is in a healthcare, a hospital in New York. The other one is in a hospitality in a hotel in New York. And I suspect something like that, a energy rebate, is down the pipeline about 6 months away from Con Ed. And I think everybody here is New York. So that's of interest to you. But as far as commissioning is concerned, and I didn't get a chance to get to it in my slides, but you guys will see it when you get a copy of these presentations yourselves. We do have a commissioning process, and we also have submittal data in our sizing program, which is going to be generated to make sure that once the system is installed, it can be commissioned so that it's operating the way it was designed to function. To make the intensity is hit on every single part of that coil.
All right. Now this next set of questions is for Ricky and Ray. For commercial buildings, what restoration cooling efficiency have you seen to the cooling efficiency back to nameplate within 5–10% of nameplate? Do you also measure coil efficiency effectiveness before and after UVC?
As far as using the Puro device on the coils?
Yeah, I believe they would be referring to your product.
Right. So we don't. I mean, we don't have any specific data on the Puro device used on coils. All of the data that we have is the clinical data of the bacterias and the viruses of what we can kill and at what distance we can kill. So if there's something that is built up on the coil, we know at what distance we can kill what bacteria.
Another couple of questions, similar and related. What is the benefit of including UVA and UVB in the Puro product? Also, what about surfaces that are not in direct line of sight? And do you have to adjust the airflow speed for effectively killing the coronavirus, for killing viruses?
Okay. So the benefit of using broad spectrum UVA, UVB, UVC. So UVC is the antiviral germicidal. That's what's going to get your viruses. The UVA, UVB have antibacterial, antimicrobial characteristics. So through the pulsing, we're looking at sometimes if you're killing the bacteria or you're shocking the bacteria with UVA, and then when you hit it with UVC, you're getting faster kills. So I don't have this specific data as to how it's more efficient. We just have the total clinical data of the efficacy on the total system and its ability to kill and in what time. As far as the question is direct line of sight, yes, you can. Your primary kill is on direct line of sight, depending on the reflectivity of some of the floors or surfaces. So let's say in a restroom, you are going to get reflective killing from the UV. But again, the data is based upon direct line of sight.
About 3 more questions. Can Puro be used in an occupied room? For small residential units, you advise against would you advise against a central air fan coil installation versus window units? And then finally, what is the cost of the disinfection process per hour or on a per day basis?
Perfect. So the Puro unit cannot be used when people are present. So again, it's designed to be automated or on demand. So it has the built-in aux sensor. So if you think about a restroom, somebody leaves that restroom, you're used to the aux sensor on the wall, the lights, the light will turn off, or when you walk in, the light turns on. This is the person leaves, there's no motion. You can now automatically disinfect that space. So you cannot be present when that's there. I don't understand the question about the in-wall air condition as it relates to room or surface disinfection.
Okay. And then I think a final question was basically about timing. It doesn't sound like the time to inactivate the virus is instantaneous. Can you identify a time to inactivate the virus based on your product's lamp intensity in the airstream?
Yeah, so we're the anticipation, right now the product is set on 3 factory default cycles. There's 15 minutes and 30 minutes. We anticipate that coronaviruses are going to be less than 15 minutes based upon all of the other studies that we're seeing in the market. It relates to UV. So there is a medical grade robot that uses pulse xenon, and they've confirmed that they can kill COVID-2 in 2 minutes using the pulse xenon lamp source. Like I said, Signify published some information today saying that they killed in 2 minutes with a constant on UV source. So it seems that more and more manufacturers are getting their hands on samples of virus strains to test and confirm, but it's really looking like less than 15 minutes to kill COVID from a surface standpoint.
2 more questions just popped in. One is, do the UVC lamps in the air handling units contain mercury? If so, is there a concern with broken lamps in the airstream? And the other is a request, is there any UV product that would fit ductless AC?
Okay, so yeah, there is mercury in the UV emitters. What we do is we have sleeved emitters. So in the event that there is a mishandling of that emitter, any of the mercury or the other gases which are producing the UVC, they will remain within that sleeve and they will not go out into the air, nor will the quartz itself. So that is an option that we do offer. We typically use those in all food processing applications, all pharmaceutical applications. as well as when there's colder temperatures, such as exist when an air handler is serving an ER or an OR room. OR rooms are typically kept at very low temperatures, and you have to understand that there is a negative correlation between the intensity of UVC and temperature. So in colder temperatures and colder environments, you start to lose intensity. These are all variables we need to consider when we're designing our equipment. But yes, there is mercury in the lamps, and a way to prevent that from ever escaping by mishandling or an accidental breakage of the emitter is by using sleeve emitters. Then the second part of the question, I'm sorry, Tim.
The second part of the question, I think that was it. Oh yeah, I'm sorry. What UV product would fit in a ductless AC system?
Okay, so, and I just want to finish up for the first part of that question. Disposal of these UV emitters is the same as any fluorescent lamps. Starlair does have a disposal program where if you would like, you can send the emitters back to us and we will dispose of them properly and send you back a certificate, an EPA certificate, saying that we didn't just throw them in a landfill, if that is a concern. But yeah, the disposal of the UVC emitters is the same as that of fluorescent lamps. And as far as these ductless units that you're seeing pop up more and more, we have other products. What we would use in this case is called our EUVC kit. And what it looks like is it's a ballast, so it's a power supply. Either depending on the size of the emitters, maybe between 5 and 9 inches long and about 1 3/4 inches thick and 1 1/4 inches wide that will get housed directly into that unit. And they come with a mounting, a spring clip that mounts the emitter into the unit, and everything is self-contained. We also have power supply boxes that can get mounted on the outside of the unit, and then the emitter itself just comes across the coil. In those cases, we just need to make sure that we're preventing any UV leakage. Like Ricky had said, there is no safe level of exposure of UV to humans. It cannot be used in exposed occupied spaces. So we do need to protect against that. Starlair's product portfolio, we have a number of different products for different HVAC solutions, especially things like that and VRFs that are popping up along, and ductless systems. We're always working on new product development to follow industry trends. But we know our best practice is to treat the air. That's a proactive solution. We don't want to be reactive. We want to treat the source. So that's why we focus on air disinfection. Oil.
And I will just mention one thing. So the Pura product uses argon as the chemical that's producing the UV. So it is different than the traditional quartz mercury lamps.
Well, I want to very much thank all of our speakers, Dan and Ray and Ricky. Thanks for a very interesting thing. That a lot was going on. So I'm going to probably go back and rewatch this. If folks give us about a week and a half to get this up online. With the speaker's permission, we will also post PDF versions of the slides. And I'll be in touch with them when we get off here. Also give us about a week or so to get those up online. Again, I will reiterate, if anybody has any speakers or topics they'd like to hear in the fall or next winter, please reach out to myself or any of the AE board members. We're going to get together in the next few weeks to set up next year's schedule. Hopefully at some point we'll be back in person. And I just want to wish you all a great summer. Stay safe and hope to see you all and at least talk to you all in the fall. Thanks again, guys.
Thank you.
Thank you.
Thank you. Have a good one.
Bye-bye.
Much appreciated.
Thanks.